Okay, now a common thing we want to do is fit a model to some data. It might be fitting a straight line, an exponential, a power law, or whatever. Now, this is definitely something Python can do. We're not going to get you to write a program to make this happen. I've already written one for you, and there are packages that help with this. What we're going to do, though, is show you how to use the program that I wrote, because you'll need to modify the program slightly to get the correct data in. Okay, let's get going. So I've produced a spreadsheet with x and y values and the uncertainty in y. That program is only for uncertainty in the y-axis. It doesn't handle uncertainties in both. You certainly can do that, but not this particular program. And I've called them x, y, and the columns. Now I've saved it as a CSV file, so File, Save As, and one of the options is comma-separated values. This is a file that any spreadsheet program can save, so it's often used as a standard way of sharing data. So if you're using something other than Excel, you can do it as that. Okay, so our first step is to upload the data. So let's go to our Google Drive, go into Data, and then we'll drag the file in there. Starting upload, upload complete. Okay, so we have testdata.csv in my drive/data. Now let's go back to my drive and go into the Colab notebooks folder. We're going to want to upload my trial program. This program is available on Wattle. You can download it from there and drag it in. So it's called LineFit, and I'll drag it in there. Okay, so let's start up the program. Double click on this. And you'll see it's a fairly chunky program, and there's quite a lot of text in because I'm trying to explain what we need to do. So it says it's linear regression code, that means to fit a straight line. It's using the stats model Python package. Not that you need to know much about that, that's just all black magic I've done. So first of all, there's a bunch of commands up here, so we'll shift return on those, which import all the packages we need. This will take a little while as it chugs through. Okay, it's asking to connect to my Google Drive, so yes, I will connect to the Google Drive, use my Google Drive account, and say allow. I told you to ask for that a lot. Chug, chug, chug. You see the spinning circle and dashes here. Wait till it's done that. It's got quite a few different packages to load. You only have to do this once, so you can then analyze many different sets of data very easily. Okay, that took 29 seconds and it's now all loaded up. Now, here is where we read in the data. Now notice I'm using the read CSV command to read a CSV. If you wanted to read an Excel file, you change that to read Excel. And then I give the full address, so content drive, my drive data, and the file is called testdata.csv. So you edit that if you had a data file that was called something different. And then it's going to show the head. Then it's going to pull out the X and Y data and the uncertainties and plot them with error bars. So let's give that a go. Shift Enter. There we go, that's all worked pretty well. It's got a nice plot with uncertainties. I'm not sure that's very much like a straight line, but anyway, we'll do our best to fit it. Now we go down to the next cell. The text here describes what it does. So we run the cell, click anywhere in it, and Shift Enter again. Chug, chug, chug. And it's done it. What it's done is it's generated a model, and it's printed out all the details of the model. Now this is a lot of stuff you mostly don't care about. But if you look up here in the text, it tells you that const is the intercept, with coef is its value, and standard error is standard deviation, and x is the slope. So for example, this best fit, it's telling you that the slope is, here it is, x is 0.4864 with an uncertainty of 0.029, and the intercept is this value with this uncertainty. So these little things over here are about all you actually care about. And finally, you can go down here and plot your model and data on top of each other. And yeah, well, I'm not sure I'd regard that as a particularly good fit, but at least it's done it. Now, why would you use this rather than doing it in Excel? Well, it can handle error bars being different on different points, and it gives you a proper uncertainty in your final result. So it has definite pluses compared to just the normal Excel line fitting.